Right, so for our game project for microprocessors, we started by brainstorming some ideas, and we eventually agreed that a Crossy Road slash Frogger style game would be a fun idea. We started by coming up with a plan for all the features our game would need to include, and of course this list only expanded the more we actually did get done. Some of our basic ideas included a HUD displaying your score, custom sprites and animations, a functioning retry system, digital inputs and outputs, a high score, some music, serial inputs and outputs, an aspect of randomness to keep it fun, a menu, and of course a functioning and entertaining game. So in this video we will break down how we implemented all these features, but first here's a brief demonstration and explanation of our game. So when you first start the game, you're greeted by the title, which is burrito.io, and a prompt to press up to start. The title comes from our idea to have the sprite, which is a burrito, jumping along the screen, avoiding people trying to eat it. So after starting the game, you'll see a sprite on the screen and begin to hear our little song for the game. This song plays the next note in its melody every time your character moves forward. So if you keep up a good pace, you get a nice little song going. See your score, that increments every time you go forward and decrements every time you move backwards. And there you'll notice the enemies you have to avoid with a little animation of their mouths opening and closing. You have to avoid these by going left, right, or forwards. When a collision does occur, the game ends, the music stops, and a menu pops up displaying your score, your high score for this playing session, a game over sign, and the option to retry. When you do retry, you can play all you like, and your high score will update as you beat it. So for music, we initially created a song that would loop the whole time the game was playing, but that just proved too much for the system to handle, as the game would run, but pressing the buttons to move was only possible for like a fraction of a second in between the delays and notes. So we compromised and had the note play every time you moved forwards. This is also probably less annoying, but here is our melody. It's stored in an array. We made the note index, aka the note that will be played, static. So when you restart the game, you keep going with the song. Our code for it is basically the same for the serial inputs as it is for pressing the buttons, but it just works like this. After checking if the button is pressed, it plays the note in the melody array of the note index. There's a small delay, and then the note index increments. When the song ends, it resets back to 0. And finally, when you die, the simplest code we had was just to have it play note 0, which is silence. One of our main points was to include some custom sprites and animations just to make the game more fun and personal for us. So we based all the enemies off of ourselves. You can see them just swapping between an open and closed mouth drawing for each of us. We used a software called Sprite on Steam for drawing all these, and then uploaded their bitmap to our code.
Hey, so I'm going to talk you through our main game logic here. You'll note that it says cars in for a lot of the variables for the enemies. So I'm going to reference them as cars, even though they are faces. At the start, we originally were inspired by Crossy Road, which is cars coming across, or the obstacles. And we kind of just kept it that way because it made sense in our heads that there were cars coming across. So that's what I'm referring to when I mean cars, when I say cars. So essentially the game starts just with a big loop that controls the traffic. So for every obstacle in the game's memory, the code does 3 things. So first it draws a black box over the obstacle's old spot to erase it, and then it moves the enemy forward based on its speed or car in the code here. So and then third, it does screen wrapping. So basically, if an obstacle goes off the right side or left side of the screen, it's a 128 pixel screen, the code moves it back to the opposite side. So it feels like they keep coming around and around and around and around, like a never ending loop of, and then after this, so we made 2 sprites. So we have an open face sprite and a closed face sprite. So how this essentially works is in order to animate them is every 200 milliseconds, it swaps between them. So they're constantly just opening and closing, opening and closing. So it just essentially animates them. So then next we have just the player movement and just the music. So the burrito character moves on a grid. So when you hit the up button, the code moves you exactly 16 pixels, which is a full lane. And every step forward you move, it's synced to a melody array. So as you move, the speaker plays the next note in the song. And we also have a down button and side-to-side controls. So, and then when you reach the top half of the screen, there's scrolling logic. So we didn't want you just to stay in the spot the whole time, because we saw the Crossy Road game, and as you move up, the screen also moves up. So how we accomplished this was, so the code resets your position and pushes all the enemies down by 42 pixels, and so it makes it look like you're actually moving up. And then we have our horizontal and down controls here. And then we have, obviously, the most important thing almost is the collision detector. But before that, we have to remove and redraw. So basically, so this checks if you move. It just erases the old position, updates where you are, and then draws it again. But it only happens if you move. So that's the flag is an input from the user, and then it just raises it and draws a new position. And then the collision, obviously. The collision basically works by checking if the burrito's box overlaps with an enemy's box, and if they touch, the game the game stops essentially. So, and then after that, it checks: is the score you've just got greater than the high score? And if it is, update the high score variable, and you update the high score variable, and it turns off the red LED. And then it shows you the game over screen. And then the game obviously gets reset. And then we have just basically every time you move, it updates the score. So if you move up one, it'll just increment your score by one, and then it'll display it. So that's basically our entire game logic. It's obviously inspired by Crossy Road, but I think we've done a pretty good job on it. Obviously the sprites, I think, help a lot to make the game and the animation to make the game feel kind of alive.
To be running through how our game radio deals with serial communications for input and output. Now, just to be clear from the start, we're using a Python controller here as well. This is to help with compatibility cross-platform. What I found is that with C, we would need to have different, more than one sort of interpreter for serial communications, depending on whether it was Mac or Unix, Linux, or Windows. But now with the Python controller, assuming, of course, you have Python installed as well as Pineput, our game will be able to run anywhere. So going back to the main.c, I'm just going to move down now to our standard output for the serial output, I should say. So we have a sort of a standard message here to sort of welcome the users to the game and to show that the game successfully compiled and is running and uploaded to the microprocessor, as well as showing the sort of basic controls. So we have WASD as a sort of movement controls, sort of classic north, south, east, west. As well as our enter key is going to be used to move to start the game or to restart the game after the character has died. So I'll just move down now to the serial input handling. So the important thing here, I suppose, is the checking the built-in function serial available. This is to make sure that our game will continue to run whether or not the user inputs a character or a command or not. so it does not stop and is not forever waiting for the user to do something before continuing. So what we're going to do is store the character that the user inputs as CMD or command, and use a switch statements to cycle through W, A, S, and D, and then from there on decide what to do with the sprite, the main character sprite. So of course the keys WASD work very similar to the physical buttons on the microprocessor. They need to be identical. So W of course will increment the melody to allow the song to play, as well as moving the character up 16 pixels, and of course impacting how the future cars will be generated. So I'll just show you the rest of the code right down to the bottom. Of course, we also have our flag set for every time the sprite moves left, right, up or down, whether it's vertical or horizontal, and how that will impact the rest of the game. So I'm just going to do a quick tutorial, a quick little run through of how it all works, or to see it live. So as normal, we're going to upload the main.c program to the microprocessor. That's really fine. And then all we have to do is run the Python controller code. We select 0 as the port, and now we're ready to go. So on my left, I'm just looking at my game now, but I can press W, enter to start the game. Sorry, W just to move on up till I eventually die. And then we'll get a quick game over screen as output to show our most recent score and also our high score. But let me play once more here. So I'm going to restart, move up. And this time I didn't do quite as well. I got 12, but of course it remembers my high score to be 19. But that's really all there is to it for the serial ports and how we're doing input and output straight to the terminal. But this allows us to play the game both using the physical buttons and using the keyboard as well on any device. So I just wanted to very quickly go over a couple of the functions we use for our game Burrito.io. So the first two I want to quickly go over is the show game begin and as well as the sort of show game over function. The show game begin, or the sort of startup screen, which of course happens when the microprocessor is turned on and connected to your laptop. This will clear the screen, make sure there's no music playing, and display the sort of title card, the burrito, as well as tap up to play, which will be interpreted as of course, the physical button on the microprocessor being hit up, and of course, same with the enter key on serial communications in the terminal there. Now, moving on from that, I want to quickly go over the show game over. Now, this is slightly similar to that. Of course, we're going to blank the screen, make sure that there isn't any music playing, and display the game over message as well as the high score and the most recent score that the user achieved. We also have a serial output there of game over and the high score and most recent score as well for the user 2 in the terminal. We also, as well as that, are allowed to restart the game by pressing up on the physical device or else the enter key in the serial communications. But that will be how our two end game and start game screens work. Now, the only other one I wanted to show was the isInside function. This is how our collisions work. So this is called to check whether or not our burrito has interfered or been hit by one of the moving cars or the moving heads. So the way it works here is it's a rectangle collision. So all four sides of the burrito are checked against, for example, one of the cars to see if the sides of the burrito overlap in any way with a pixel of the cars. And if all four cases are true, all four sides, then of course we have a hit. And then our LED will be switched on, our red LED, just to show to the user both, of course, in game, in the terminal as well, and on the actual microprocessor with the red lights that it's game over and a collision has occurred. But that is essentially it.